So last time we learned that we can transfer a force. Say this is a force, and this is the line of action, which means you can transfer the force at any point on this line of action without changing the system, right? So last time, hoping that you have already watched the video, we watched that we can transfer this force. If you want to transfer the force to another point, say which is t distance away from the line of action, you can do so, but you have to introduce a couple g, which is equal to f into d. D is the distance between these 2 points, right? So this is what you have to do. If you won't transfer force, you can transfer it, but you have to introduce a couple, which is equal to ft. Now notice that if you have a force and a couple, you can also transfer it back to a single force alone with no couple there. Couple is 0, right? So this is vice versa. You can go from here to here or from here to there, right? So how do you find the distance? G divided by F equals D. This is the necessary distance you want. Now the most important thing about this is that when you're talking about rigid bodies, you know that the forces can be applied at any point, so they don't meet at a single point. So what if we can transfer all these forces to an arbitrary point, something that you select, right? If you can transfer all these forces to an arbitrary point, you know these forces will act at this point, and you have already learned about handling forces at a point, so it'd be easy. Now you already know how to transfer a point, so we'll look at now a system of forces, which means that we have any number of forces, and using the previous theories we can transfer it to any arbitrary point. So let's select a coordinate system. This is x, this is x, this is y, right? Let's say that there's a force acting F somewhere here, which is at a point x comma y, right? I'm just gonna name it. So now you know from the basics that you can resolve this force into two components. So I'm gonna name them fx and fy, right? So what I'm gonna do now, if I want to transfer this force to a specific point at O, right? So instead of focusing on this force alone, I'm just going to focus on the components here, right? So I want to transfer fx here. You know I can do it, but you have to introduce a couple. So what is the distance from here to here? This is y. Y is the distance. So I can write fy here, fx here, but I have to introduce a couple. Let's say this is gx, which is equal to fxy, right? And now I want to transfer fy here. Likewise I transfer it fy. Now look at this. The couple or the moment it applies is in the anti-clockwise direction. So I'm gonna draw another couple here, which is called gy. So gy is what? What is the distance? X is the distance, right? Gy is fy into x. I hope you can say this, right? Now what do we have? We have transferred this force to an arbitrary point. by introducing a couple. We have now two couples here. So we dealt with the moments, we can sum these two couples as well and get a resultant couple R, which is gx gy, since anticlockwise direction couples are taken as positive, minus gx, right? So finally we are left with this Cartesian system. You have fx here and you have fy here, and you have a resultant couple, right? So what do fy and fx give you? They give you back the force, right? Now we have successfully transferred the force from a point, a general point, to an origin, right? So we can do this for all the forces that are available on the plane, and so we can treat them all. Let's say that, sorry about it, let's say that we have like F, P, so many forces. I'm just gonna draw, this is Q, right? So we can transfer the force here, F, and this transferred here, P and Q, this direction. And also I have to introduce a couple as well. All the couples from each of these forces summed up gives you a resultant couple. Then I can erase these things. Alright. Okay, now you know you can work with components instead of the forces. Then you have what you can do is you can calculate all the xi's of the forces. Let's say this fxi, I represent a number, right? fx1, fx2, fx3, likewise any number of force, and you can get fyi likewise, right? So this will represent, so these are a single component of a force, that is called fi, right? So if I summed up all of these forces, or the components of all these forces, let's say fxi, we can name it, or we can call it the x component. Okay, what about this yi, which means all the y components of all the forces available? This is y component. Now if you know x component and y component, these are the components of all the forces available, right? Now you can find the resultant force. How do you find the resultant force? Which is given by x squared plus y squared and the square root of the whole thing. That gives you the resultant force, right? What is the angle? Angle is given by tan inverse y over x. This is the angle, right? But not only this, we have, in addition to these forces, we also have a couple, right? Okay, at the end of this we can get, after summing up all the components y, x, you will have a resultant force and a couple g, right? The resultant force, I will write it x squared plus y squared, and this theta here, tan theta goes y over x. What about the couple? Couple is given by as you have seen in the beginning of the video, all the fx into y components, right? So this will give a clockwise moment. So I will write it as negative, and all the y components of x, that gives you anti-clockwise moment. Fy into x's. X and y will be a general Cartesian coordinate points, Cartesian coordinates, right? So all this summed up will give you a couple, right? So now you know the couple and the R. So we have found everything you need now. Okay, thank you for watching.